Hello everyone. Today we learn about complex numbers and its properties. Complex numbers. In the field of real numbers, the equation x square plus 1 equal to 0 has no real solution. To permit the solution of these and similar equations, the real number system was extended to the set of complex numbers. Euler introduced the symbol I with property I square is equal to minus 1. He also called I as the imaginary unit. A number of the form a plus ib, where a, b are real numbers, was called complex number. If we write z is equal to x plus iy, then z is called a complex variable. Also, x and y are respectively called real and imaginary part of z. Sometimes we express z as z is equal to order pair xy. We also write real of z, that is rz is equal to x, and iz is equal to imaginary of variable z is equal to y. If x is equal to 0, then from z is equal to x plus iy we have z is equal to iy. Then z is called purely imaginary number. The complex conjugate or conjugate of z is equal to x plus iy is z bar is equal to x minus iy. For example, conjugate of minus 2 minus thrice I is minus 2 plus thrice I. If z is equal to x plus iy, z bar is equal to x minus iy, then real of z is equal to z plus z bar by 2, and imaginary of z is equal to z minus z bar by twice I, where z bar is conjugate of z is equal to x minus iy. Equality of complex numbers. Consider two complex numbers z1 is equal to x1 plus iy1 and z2 is equal to x2 plus iy2. Then z1 is equal to z2 if and only if x1 is equal to x2 and y1 is equal to y2. The phrases greater than or less than have no meaning in the set of complex numbers. That is, any two complex numbers are not comparable. Fundamental operations with complex numbers. Addition. A plus ib plus c plus id is equal to a plus c plus I into b plus d. Subtraction. A plus ib minus c plus id is equal to a minus c plus I times b minus d. Multiplication. A plus ib into c plus id is equal to ac minus bd plus bc plus ad. AC minus bd plus I times bc plus ad. Division. A plus ib by c plus id is equal to a plus ib by c plus id and multiplying numerator and denominator by c minus id. This is not c plus id, but it is c minus id. This is c minus id. So multiply numerator and denominator by c minus id, that is conjugates of c plus id. This gives numerator becomes ac plus bd plus I times bc minus ad, and denominator becomes c square plus d square, because this is c square minus I square d square and I square is equal to minus 1. So this is c square plus d square, which is equal to ac plus bd by c square plus d square plus I times bc minus ad by c square plus d square, where this quantity is real part and this quantity is imaginary part, provided c square plus d square is not equal to 0. Absolute value. The absolute value or modulus of a complex number z is equal to a plus ib is denoted by modulus a plus ib and is defined as modulus z is equal to modulus of a plus ib is equal to under root a square plus b square. Therefore, modulus z square is equal to a square plus b square. By squaring this quantity both sides, we have z modulus z square is equal to a square plus a b square is equal to a plus ib into a minus ib is equal to z into z bar. Therefore, modulus z square is equal to z into z bar. Similarly, we can show that conjugate of product z1 and z2 is equal to product of their respective conjugates, that is z1 into z2 whole bar is equal to z1 bar into z2 bar. Geometrical representation of complex numbers. Consider the complex number z is equal to x plus iy. A complex number can be regarded as an ordered pair of reals, that is z is equal to xy. This form of z suggests that z can be represented by point P whose coordinates are x and y relative to regular axes x and y. O is origin and this is x axis, this is y axis, this is real axis and this is imaginary axis. So position of the point z, this is z is equal to x plus iy, then we have to go x unit along x axis and then y unit along imaginary axis, then this point P whose coordinate is x, y. To each complex number there corresponds one and only one point in the xy plane, and conversely to each point in the plane there exists only one complex number. For this, the complex number z is referred to the point z in this plane. This plane is called complex plane or Gaussian plane or Argand plane. The representation of complex numbers is called Argand diagram. The complex number x plus iy is called complex coordinate. X, Y axes are respectively called real and imaginary axes. The distance between the points z1 is equal to x1 plus iy1 and z2 is equal to x2 plus iy2 is modulus of z1 minus z2 is equal to square root x1 minus x2 whole square plus y1 minus y2 whole square. The complex number z is called affix of the point xy which represent it. Polar forms of a complex number. Consider a point P in the complex number z is equal to x plus iy. From the adjoining figure this, we have x is equal to r cos theta, y is equal to r sin theta. Here this is the point pxy, this distance is x and this vertical distance is y. Then from this diagram, x by r is equal to cos theta, that is x is equal to r cos theta, and y by r is equal to sin theta, so y is equal to r sin theta. Then r is equal to under root x square plus y square. Here r is equal to under root x square plus y square is equal to modulus x plus iy is equal to modulus z. Therefore, modulus z is equal to r and theta is equal to tan inverse y by x. Also, z is equal to x plus iy is equal to r cos theta plus I sin theta is equal to r times e to the power I theta. It is called polar form of the complex number z. R and theta are called polar coordinates of z. R is called modulus or absolute value of z. The angle theta which the line OP makes with the positive x-axis is called argument or amplitude of z. It is also written as theta is equal to amplitude of z or theta is equal to argument of z. So therefore, r is the modulus of z and this angle theta is known as amplitude or argument of z. The argument of z is not unique. Since the equation z is equal to r e raised to the power I theta does not alter if we replace theta by 2 pi plus theta. So, theta can have infinite number of values which differ from each other by 2i pi. That is, if this angle is theta, if we rotate 2 pi angle, that is 360 degree, then it again becomes theta, that is 2 pi plus theta. Again, if we rotate anticlockwise, this is 4 pi, this is 6 pi, etc. So, theta can have infinite number of values which differ from each other by 2 pi. If a value of theta satisfies z is equal to r e raised to the power I theta and lies between minus pi and pi, that is minus pi less than equal to theta less than equal to pi, then the value of theta is called principal value of the amplitude. Properties of arguments. The argument of the product of two complex numbers is equal to the sum of their arguments. That is, argument of z1 z2 is equal to argument z1 plus argument z2. Proof. Let z1 is equal to r1 e raised to the power I theta 1, z2 is equal to r2 e raised to the power I theta 2. Then argument z1 is equal to theta 1, argument z2 is equal to theta 2. Now z1 z2 is equal to r1 e raised to the power I theta 1 into r2 e raised to the power I theta 2 is equal to r1 r2 into e raised to the power I theta 1 and into I e raised to the power I theta 2, which gives r1 r2 e raised to the power I theta 1 plus theta 2. Therefore, argument z1 z2 is equal to theta 1 plus theta 2, which is equal to argument of z1 plus argument of z2. Another property, the argument of the quotient of two complex numbers is equal to the difference of their arguments. That is, argument of z1 by z2 is equal to argument z1 minus argument z2. Proof. Let z1 is equal to r1 e raised to the power I theta 1, z2 is equal to r2 e raised to the power I theta 2. Then argument z1 is equal to theta 1, argument z2 is equal to theta 2. Now z1 by z2 is equal to r1 e raised to the power I theta 1 by r2 e raised to the power I theta 2 is equal to r1 by r2 into e raised to the power I theta 1 minus theta 2, which implies that argument of z1 by z2 is equal to theta 1 minus theta 2 is equal to argument z1 minus argument z2. If argument z is equal to theta, then theta is not unique. Twice n pi plus theta is argument of z. When n is equal to 0, plus minus 1, plus minus 2, plus minus 3, plus minus 4, dot dot dot. The value of argument such that minus pi less than equal to theta less than equal to pi is called principal value of the argument. Result. Argument of 0 is not defined. Argument of positive real number is 0, as 3 is equal to 3 times e raised to the power I0. Here blue line represents z is equal to 3, whose real part is equal to 3 and imaginary part 0. So this line makes 0 degree with positive x-axis or positive real axis. Therefore, argument of this positive real number is 0. This is 3 is equal to 3 into e raised to the power I0. For this, argument of positive real number is 0. Similarly, argument of negative real number is plus minus pi, as minus 3 is equal to 3 into e raised to the power I plus minus I pi. Here red line which represents minus 3. So it makes either angle pi or this is minus pi. This angle is pi and this angle is minus pi. Therefore, argument of negative real number is plus minus pi. This anti-clockwise angle is pi and this is clockwise, this is minus pi. Therefore, its argument is plus minus pi. Argument of complex number, that is argument of ib is equal to pi by 2 if b is greater than 0. ib means this is along imaginary axis. If b is greater than 0, then b lies above x-axis, and this angle gives then this angle gives pi by 2 if b is positive. This is pi by 2. So argument of iv is equal to pi by 2 if b is positive, and if b is negative, then its argument is minus pi by 2 or 3 pi by 2. This is minus pi by 2 if b is negative. This is minus pi by 2, or this is 3 pi by 2. This is 3 pi by 2. Now problem 1. Argument z plus argument z bar is equal to twice n pi, where n belongs to z. Let z is equal to r e raised to the power I theta. Now argument z plus argument z bar is equal to argument z into z bar is equal to argument r e raised to the power I theta dot r into e raised to the power I minus theta. This is equal to argument of r square, and this is equal to twice n pi, because argument of positive real number is 0, and in general its angle is twice n pi plus minus alpha. For r square is equal to r square e raised to the power I into 0, and general value is given by theta is equal to twice n pi plus minus alpha is equal to twice n pi plus minus 0 is equal to twice n pi. So argument z plus argument z bar is equal to 2 times n pi, where n is an integer. Argument z minus argument minus of z is equal to plus minus pi. We know that argument z by z1 by z2 is equal to argument of z1 minus argument of z2, and argument of negative of real number is plus minus pi, where c is a positive real number. Therefore argument z minus argument minus of z is equal to argument of z by minus of z is equal to argument of minus 1 is equal to plus minus pi. Thank you very much for watching. Please don't forget to subscribe my channel. Please like, share and comment. Please press the bell icon to get notifications.